My name is Bill, and today I'm going to introduce our project, which is a compact process control system. So basically, we have 4 individual progress on our one system. Here, first of all, we have a pressure sensor here, and we're going to pump the water from this tank into this tank and to compress air inside so we can read the pressure on this gauge or on our HMI. And the second one, we have a heater here and a temperature sensor. We're going to heating up the temperature in this tank and to measure the temperature and monitor it. Then we have a flow rate sensors here. We're going to control the flow rate going through this pipe. And the last one, we have this tank. You can see the scale on it. We're going to pump the water from this tank to this tank and use the ultrasonic sensor here to measure and monitor the water level inside this tank. Now I'm going to start with the pressure tank here. And see on HMI, we have a reading gauge. We have actual reading, the current set point, and the control buttons, and the pressure gauge animations here. To do the pressure control, make sure that you close this manual valve, open this one, close the rest of the manual valves. Each of them. This one you can just leave it here, and this one. Okay, here we go. I'm going to enable the system. Give the set point here. I'm going to give 120, and the unit is the millibar. Active. The pressure reached to the set point here, a little bit overshooting, but it's going back. It's getting close to the set point over time. Once the reading value reaches to the set point, the system will slow down the pump or shut it down to keep the pressure inside this tank constantly. And also, we can monitor it here. Now I'm going to restart the process, stop it, release the pressure by this manual valve, and you can see that pressure go back to 0 now. We can also monitor the reading of the pressure in the table here. Now I'm going to restart the progress. This time I'm going to give the set point as 140, and then you can see on the table the right line is the set point and the green line is the current reading of the pressure. Start it. Pressure is increasing and reach to the set point. There's a little bit overshoot, but it's going back to the set point immediately. And if you can hear that the system is actually adjusting the pump to the valve here, and to control the pressure, let it constant and keep it constant as the set point here.
Whoops, it's a
little bit overshoot. So actually in our system, there's a little bit offset. And the reason could be the water, the amount of the water inside the tank. Sometimes you need to readjust the system, the parameters, to get the real, the perfect situation of the system. Now here you can edit all of the parameters in this screen. You can read them here. I'm going to download the current parameters of pressure control, and here you can actually monitor all of the parameters currently you have, or you can edit them. And this is for the pressure control. Now I'm going to do the flow rate control here. On this screen, you can see that we have a gauge and reading and set point, and as just as same as the pressure control. To do the flow rate control, you need to open this manual valve and make sure that close the rest of them. Close this one, and these manual valves. Now I'm going to enable the system. Give the set point. This time I'm going to give 2 liters per minute. And start the system. You can read that the rating of the flow rates is increasing and reach the set point, keep constant. Also, you can monitor it in the plotting. I'm going to give another set point here. I'm going to give 3. Same thing, red is the set point and green is the current reading. Very close to the set point. That's all of the flow rate control here. Now I'm going to the third progress we have is the level control. You can see we have an animation of the tank, and now I'm going to activate the system, give the set point. I'm going to give 150 here, and before that, make sure you close this manual valve, close this one here, but open this one, and make sure you open this one too. Start it. You can see the system is pumping the water to that tank. So once this flow switch is active, this valve will open and let the water go back to this tank. And the water level in this tank is still increasing to reach the point.
I don't think I can go up to 150 because this tank will be empty.
Yeah. I think that should work because I tried it before. It was like this, yeah.
Okay.
We will see.
It's taking a while.
So one thing you need to pay attention that don't let the water level decrease lower than these pipes. Otherwise, the pump will suck airs inside to the pipes. That will damage the pump.
Oh. We programmed in safety features that disable the pump once the water level is below the capacity sensor.
Here's the capacity sensor we have. So once this one is triggered, the system will shut down the pump.
It's very close. I don't think you can. That sensor might not be triggered. I don't know.
Sure works. Could be reached here. That's the dead one.
It was working very fast before. Did it change? Because I remember it was working really fast before.
To the third process, the water level control. And here I'm going to activate the system. Here I'm going to give the set point as 120, which is the height in the tank, and start it. Oh, make sure that you close the manual valves here and here, and open this one and this one too. Start it. Okay, once this flow switch is active, this valve will open, let the water go back to this tank. So actually it's an adaptive control system. The system will adjust the parameters used in the PID's instruction and control the water level, keep increasing to reach to the set point. So now the reading value is very close to the set point. The system will slow down the pump or shut it down, but keep the pump working. So the water level will keep constant in the tank. Now I'm going to show the bolting of it. Here I'm going to give another set point, which is here I'm going to give 80.
Did you start?
Take a little bit. Since the set point is lower than the current reading, so the system will shut down the pump for a while. And you can see that red line is the set point, green line is the reading. The reading is exactly as same as the set point here. And that's the process of the water level control. And I'm going to give one more set point here. I'm going to give 120 again. You can see that it will increase.
Why is there such a reading delay? It's 105 now.
It's increasing slowly, but eventually it will reach to the set point over there. And that's it. This is the whole process of the water level control. Now I'm heading to the next process, which is a temperature control here. I'm going to enable system and give the set point like 25. Oh, 30 would be better, easier to observe.
It's gonna take a while.
Yeah, since the okay, so system is started, and now you can see that the pilot light on the heater is flashing. That means it's adjusting the output of the heater.
Yeah, okay.
See that the temperature, the green line, the reading of the temperature reached to the set point here, and it won't increase anymore. But you can see that a little bit offset, but it will go back. You can see that the light here is flashing. That means the system is adjusting the output of the heater to decrease the rate of the increasing of the temperature.
That's it. This is Yuling. I'm responsible for doing the PLC programming for the Festo Compact station. And so here we have our PID, enhanced PID block. So instead of using the regular a formula for the PID, this one is actually using the velocity, which means it's calculating the output through the rate of change of the error versus the actual error values itself. The advantage for this is that you can change your PID gains as the process is running, which can be very good if you need to do some adaptive controlled adjustments. So here we have our individual proportional, integral, and derivative proportions for our control. I chose for the independent type, and these are the parameters for how the error is being calculated. And then here we have our maximum output. I chose this number because our output card at maximum output is this number of counts because it's an 8-bit analog card, and so these are our control variable limits. And then here are multiple variables that could be changed. There are a lot more built into this PIDE control block. You can set the maximum and minimum for every parameter, including your integral, to prevent your integral from ramping up infinitely, to tell you if your system is unstable. All of these can be controlled and viewed from the HMI as well. And then here is the auto-tune function. The built-in PIDE block that we're using uses a open loop response type for its PID tuning. So you you must stop your process in order for the PID loop to be tuned for the best results, so it doesn't have as much oscillations versus if you were using different methods. So it has an internal algorithm. I'm not 100% certain which algorithm is using, but I don't know what else to say. I don't know. So aside from the PID block, which is what we use for every single parameter, we have our error conditions, and which depends on what the outputs and inputs. You can't have both modes of control for your motor, which is analog and digital. So this is the digital heater PWM, and then this is the motor PWM. And then also there's the built-in safety. For every safety condition, these can all be viewed on the HMI to tell you which parameters are out of bounds, and to prevent your system from overheating or your pump sucking in air, or the tank from overflowing.